Thank you very much, Jurian, for your perspective as a product owner on microservices. Um, I'm now going to give my perspective, and that is one of a software engineer and software architect at Van der Bron. Um, I decided to join Van der Bron in 2015, within a year after the company was founded. Before that, I've always been working in healthcare IT, um, but I had become increasingly interested in renewable energy and the energy transition. Um, and one of the advantages of being a software engineer is that you kind of can choose in what sector you want to work. Um, so yeah, you can work on products that you think are important and actually care about, if you choose to do so. And yeah, at Van der Bron, I'm in the capacity of software architect. I'm responsible for software engineering in general. Yeah, so microservices. Um, this is not the first engineering paradigm to come along in the industry. Yeah, there have been many trends and developments. In general, I would say that the industry is moving forward. I think we are getting better at managing complexity, which to me is managing complexity is like the main task of software engineers. Um, but on occasion, um, trends are hypes, and not everything, every innovation or invention sticks in the long run. And sometimes I think I get the feeling we even go around in circles. An example of that is SOAP versus JSON REST communication. Like in the 90s, we had SOAP, which is a XML-based data exchange format, and yeah, it was considered too difficult by software engineers, and they wanted to move faster and build things quicker, so they threw away almost all the principles of SOAP and started with a very simple format, JSON, where you just have a few basic types. But over time, yeah, as the software that was built on JSON also grew, um, yeah, the lack of any schema which came out of the box in SOAP became an issue. So now we have standards like Swagger and OpenAPI 3.0 that try to mitigate that. And security was also thrown away with the bathwater, but it's actually quite important. So now we have JSON Web Tokens. So all these things that SOAP had are slowly being added in again. So with with microservices, I think we also approached it with interest because there's always something interesting in these new developments, but also with some caution. Um, because we were afraid, I think, to fall for the cargo cult anti-pattern. Um, I don't know if you are familiar with this real life phenomenon. It happened in the last years of the Second World War when the United States were fighting Japan, and they had to cross the Pacific to do that, of course, and that's why they used a lot of the small islands in the Pacific to land their um, airplanes for refueling and things like that. But there were people living on those islands, and they had never seen planes. So yeah, to them, these people, these American soldiers, they looked like gods or demigods, and they um, saw that they brought a lot of interesting stuff then with like food and fuel and they would also like to have those things. And since they didn't understand the deeper workings of what was going on, to them they just looked like religious rituals. So they built their own control towers and even planes, all using wood. Um, and they marched along and things like that. So trying to mimic the rituals as good as possible. But of course, the cargo wasn't delivered, and their planes didn't fly. So yeah, that the same basic idea can also happen in software engineering. If we jump on the bandwagon, the microservice bandwagon, without, for example, knowing what problems it is supposed to solve and what the trade-offs are involved. Because, yeah, in software engineering, there are very few hard truths like that you can have in computer science. You can say, okay, this is the fastest sorting algorithm. I can even prove it mathematically. But in software engineering, it seems to be always like, what is the best solution? It depends. And yeah. Um, so, okay. Microservices at Van der Bron. What did it look like before microservices came along? Well, of course, like with any startup, you start with a single service, as did we. There was a website and there was a backend. And it was, in that sense, a very simple solution. All our functionality was in a single backend, and um, we built it using Scala. Um, and we could also scale our capacity if we wanted to, just horizontally by having multiple instances of the backend. And deployment was also simple because there was never any doubt what needed to deployed or needed to be deployed or in what order, because there was only one. Um, but you could ask yourself, was it really simple? So yeah, from the deployment perspective, yes, one service is simpler than 20. Um, but in other aspects, the functionality was quite complex. And here I'm using the definition of complex that I stole from Rich Hickey, who the inventor of the programming language Clojure, who defines complexity derived from the Latin word from complex, and apparently there it means it's related to things that are braided. So different concepts that are mixed together. So yeah, Julian already referred to spaghetti, which is highly complex, where everything is entangled. And if you look at our source code, I think there was also a lot of entanglement indeed. So yes, spaghetti, but maybe also closer to lasagna. Well, I will show you some of our code. So we have a lot more folders now, but in the beginning we just had client, which was our JavaScript front end, and we had server API, which was our Scala backend, and we still have that. I mean, if you build a monolith, it tends to stick around. Hopefully, it gets smaller over time, but it's probably not going to disappear tomorrow. And within that, you see we have a lot of folders without little hierarchy. So it's a very flatly organized code base. and I think it's organized in layers in as far as it's organized. So, for example, we have a layer here that's called DTO. Here we have all the definitions of the objects that we expose. This will also be translated into JSON. Um, and they're all kept together in one neat 1,000 line file. Um, so but what we see here, there's a person object. There are things related to meter readings. All domains are in one file. So the logic is more organized by kind rather than by domain. Here we have all our clients. So these are the clients that take care of the communication with the system that our backend talks to. You can see there's like 7 different clients. So this is the communication layer with our uh, other systems that are further in the backend, like our databases and ERP systems and stuff. Um, so like I say, it's layered in a way, so it's maybe a bit more like lasagna, but we definitely also have spaghetti. Um, for example, here we have a consumer orchestrator which orchestrates a lot of different stuff, and here we have, I think, like 12 different dependencies, which are of course way too many. It's hard to keep track of, and so yeah, a lot of this code also then is quite daunting to new developers. And you might ask yourself, yeah, how could you let this happen? Um, and that's a fair question, but because of course we can organize our code differently even without microservices. Why didn't you create more packages or have more of a hierarchy in your in this code base? Um, but yeah, I mean, there's always a pressure from people like Jurian, the product owner, that wants the value being delivered, and which is of course he should be wanting that from his perspective. So there's some pressure to get stuff done. So developer might look, okay, I need a Salesforce client and I need advanced payment orchestrator for this functionality. So I will add it in here because everything I need is already here. But yeah, then over time, more and more stuff gets added, and once you have reached a certain level of complexity, it tends to get exponentially worse because has become so complex that people will not refactor it anymore. They don't understand it anymore, so you don't dare to rearrange it, and that's a very critical point. Um, so yeah, I think we recognize that the microservice could help us combat these problems. Yeah, I already mentioned that like the pasta based architecture meme. So indeed, spaghetti. Like I said, that we had a bit of lasagna in there as well, and service and um, microservices are sometimes compared to ravioli, where you have all separate blocks. Every microservice is a block, but I would argue that within these blocks, it's lasagna again. So within these blocks, you still have your layers, and I think that is something also to aim for. Um, okay, so what are the promises of microservices? Jurgen already mentioned them. He mentioned 5. I will focus on 3 of them because of the limited time. And the first one was maintainability, because the teams can have the responsibility and ownership of specific bits of functionality, which are then vertically sliced through all the layers. There is the promise of scalability. You can scale different parts of functionality based on the needs more dynamically. Um, and there is more autonomy for different teams that uh, they can focus on. For example, if we have a team focused around our electric vehicles, they only need to know about. They need to become specialized within that domain, and they can take ownership also from for the whole all the use cases that are related to that. So maintainability. This is of course very important. The code that I just showed you here. This is not very maintainable because of the complexity, all the dependencies in one place, and microservices force a promise that complexity uh, can be limited because something I just showed you is pretty much impossible to do with microservices. Um, Adding a new dependency in this situation was probably too easy, and that's why it happened. If it's an entirely different service, well, there you might think twice before adding a dependency, because that means you have to do a request over the wire. You have to serialize your request, and you need to talk to an API, etc. Um, another thing is that the feedback loop in our development might be quicker, because we can have quicker deployments. If we deploy one service that is faster than our monolith, which could run into more than half an hour to build and deploy, which is still quite okay. Some software, there's the term nightly build, which had to be taken quite literally. It took the whole night to build everything and deploy everything. Um, so yeah, that's another promise. Um, Immediately, also what we saw in this as a threat is that it took a long time, this deployment, but it was also simple in a way that there was never any doubt that what needed to be deployed, because the whole thing was deployed as a package, the front end and the back end. Well, if we start to split up things, we need to can deploy things separately, but it's good to keep dependencies to a minimum, but the minimum is always at least one. A service with zero dependencies is pretty pointless. So you need to think about that with deployments. Another threat that we saw was perhaps duplication of functionality, because all these services always need to do similar things. They need to log their stuff. They need to do their HTTP requests. And if we separate everything nicely, it might result into the wheel being reinvented many times, and then we still have not maintainable software, because duplication of functionality is also a guaranteed way to make your software unmaintainable. Um, we also saw some ways that we could perhaps mitigate these threats, and one of them is to detect potentially breaking changes early on, so that we are aware of our dependencies and that we can fix them before we deploy them, and then we find in production that we have a not working combination of services. So we also recognize that we had to invest quite a bit into our continuous integration and deployment. So that's what we did. Um, We also wanted to start small, of course, with this whole new concept of microservices. And there was one part in our application, there was one endpoint basically that had the humble task of converting HTML to PDF. Our contracts, they are created in HTML and then converted to a PDF and sent to our customers. But you can imagine this is such generic functionality that it might also be used in other use cases. Um, so we have a microservice now with just one endpoint, which used to be one of the uh, many endpoints in our monolith. Um, and there was another complication here with HTML to PDF is that it depends on a native library that we then had to make sure was installed on our single service and with the right version, not having any conflicts with other libraries that we had installed, which is harder and harder to do the more libraries you have, of course. Um, and there was also a danger of this process is not streaming, so it can use quite a lot of memory. So if we have a lot of HTML to PDF requests, we might bring down our entire server on our website, for example, even though this has nothing to do with converting HTML to PDF. So yeah, that's the first one. We converted. Now we have a single service here with just a tiny little bit of code that does exactly what it says on the tin. Um, so yeah, that was a first good experience. Of course, we had to make sure this thing gets deployed. So we had to do had a bit of overhead in doing that. But in general, we were quite happy with this. But this functionality is so simple. It's maybe not even a microservice, but more like a nano service or something that it in itself it doesn't give us confidence yet on whether microservices as a whole are worth the effort. So we looked for another candidate that was a little bit more with a little bit more meat on it, and that was our invoices. What became eventually our invoices microservices service. Because well, on our website, this is our Van der Bron, my Van der Bron environment, where people just can see all their invoices and their payment status. But we don't have just one product. We have also we have energy, the utility company part of our company, but we also have electrical vehicles and we have energy production. And all of them have also have invoices, which we implemented in separate endpoints on our monolith. But they were doing very similar thing, but developed by different people and different teams, so all in a slightly different way. Um, and we thought that this is really not domain specific. Whether when we're talking about invoices, it doesn't really matter whether it's invoices for electric vehicles or for their gas consumption. So this is a domain in itself, invoices, and so that was the second candidate to become a separate microservice. Um, which now we have. It has just two endpoints for fetching and downloading, giving an overview of the invoices and downloading them. The yeah this is what the service does is there's the API, which is now the invoices service. It fetches information from our one system and combines it with information from the other system. There is a system that maintains the payment status of the invoice, and the other one that just has the overview of the invoices that we've issued to our customer. So what does it look like in our code? Um, I will show you that in a minute. Right. Um, So the invoices service um, again has layers in the same way that our monolith has. Um, there are the clients again that maybe you remember from before. I'll show you just real quick. In the monolith, we had a long list of clients. In the monolith, we have only two clients, namely the ones that need to talk to these two different systems. Isido and Navision is what they're called. And there is a single route. This is where all the requests come in and are mapped to their handlers. There is a package object which was more than 1,000 line in the monolith, but here is just 60 lines, and it contains only the fields for the invoice. Nothing more, nothing less. And then the clients have their own business objects, which are fetched from these services and converted from JSON into these case classes, which are just plain data objects. So you see that that this is the dependencies here are limited to just these two systems, and in fact, as for in case of this Navision, which is the system that takes care of the payment status of the invoices, this is the only service in our entire company that in our entire code base that talks to this system. We do have a bit of duplication. So if we look at the organization object, which here has only one field, this is an object that we have in many places. It's used as a connection. Everything is filed on an organization. It's sort of a connecting object. And in our monolith, we also had this organization, but here you see it has a lot of fields. And God knows who might be using these kind of fields for whatever use case. That makes it hard to maintain, because you cannot remove anything without breaking changes for somebody else. And it is clear now, in spite of this object being duplicated, it is clear that we need this here only to get the organization ID and nothing else. So what we see with when you decomplect, so when you unravel the braid, is that you get a lot more things, but they're completely separate. So in terms of the code, there is duplication. Even there are different organizations. Well, you could see here we had about 6 of them. But they are tailored to their use. This is also a software engineering principle that it's better to have multiple specific interfaces than one big one that is supposed to fit all purposes. This was, I don't know if this was exactly the second thing, but this example gave me confidence that this whole microservice thing was probably going to improve our code base. Because if we have a new developer in our company and they need to do something with invoices, they know exactly where to look, and they can only in their mind they only need to put a few things like the two systems it's talking to, but not all the other things. Maybe we could have also done this within the monolith reorganize the code, but yeah, but we didn't, and this this forces us to do that. Um, there is a price to pay for in terms of deployment, because yeah, as I said before, deploying multiple services and orchestrating the deployment is not trivial. So we've invested quite a lot of time in that, and we have a mechanism for detecting which services need to be deployed. Ideally, only one or two need to be deployed together, because if we run into a situation where all of them need to be deployed all the time, then we have the famous distributed monolith situation, and that's actually worse than having a single monolith. So we don't want to get there. Yeah, I won't go into details on how we implemented this CI/CD, but yeah, I can say that it has been a considerable effort. Right. So the second promise, or of the five that Julian also mentioned, is scalability. Of course, if we have different services running at the same time, if, for example, we would find out that invoices suddenly are in high demand, we can easily scale just the invoices services. We can scale them horizontally or vertically to our needs, without needing to scale our monolith up to massive proportions, even though all the other functionality doesn't need to be this have this much hardware thrown at it. So yeah, that could potentially be a benefit, and but I would say that in our case, this hasn't been a very important selling point for microservices, since we have ultimately we a lot of our services talk to other third-party systems or databases, and that's where the bottleneck tends to be. It's very rare that the pressure is at the service layer, so that so it's unusual that we need to scale that up. There is even a drawback that if since we have, let's say, I think we have 26 services now. Since these are run as separate processes, separate Docker containers, all of them are constantly kept alive and allocated a certain amount of CPUs, even though they might not need that all the time. But if you would scale that down, if you put, say, assign like a single CPU to that service, it would become very slow. So I think in total we will probably be using more resources in our cloud provider than if we had a single monolith. There is a mitigation for that. That's the serverless model, where you pay per request, and then the cloud provider takes care of linking this to resources. But yeah, we haven't gone that way yet, and that would again be an investment in being able to deploy there, and I'm sure there would be drawbacks as well. One thing in which we did have a benefit from having multiple microservices is that our single monolith, as you saw, it talks to many other systems, and these are all HTTP requests, and they tend to use the same resources. They are connected to the same network line and are using, technically speaking, the same connection pool. They're all drinking from the same pool, which meant that in some cases there was increased traffic on one of the endpoints, which then brought the website down, even though they had nothing to do with it, which is, of course, not something you want. This is something we could have also addressed by just in code creating separate pools. It takes some management and some effort, but it is, we could have done that much more efficiently. But this is just a problem you don't need to worry about because by definition these microservices are using their own set of allocated resources. Then the topic of autonomy. There is a promise that teams can be organized around the domain vertically through all layers. So you might have some people who focus on the back end, you might have some people who focus on the front end, or people who are full stack and do everything. Um, um, so and it even allows you in principle to use the technology, the language or libraries database that are most suitable to the particular task that you are solving. This is a powerful thing. I think the HTML to PDF is an example of that. We need a certain library in that case, so we can use it there without exposing that complexity to anybody else. However, it is possible to for example, create one service in Go, another one in Scala, another one in Ruby or whatever, just because of preferences within the teams. Um, but I think there would be a very high price to pay for that if we just let that happen, because yeah, since we have sort of a ravioli architecture model, uh, the layers within those microservices are potentially reusable. So and we do that extensively. Um, but that becomes virtually impossible if we use all kind of different technology stacks. So I would say this is a possibility, but it's definitely also a very big threat to embrace this autonomy too liberally. And there's also a potential consequence, that you get more siloization within your company. Yeah, that like for example, you have a Node.js team that doesn't really talk to the Scala team, um, and yeah, I think that's always a danger for companies that grow bigger, and that's why um, um, startups can often outperform big corporations, just because they actually talk to each other. Um, and yeah, so that's also a threat I see in using microservices. And we have taken some mitigations for that. One important one is that we have decided to put all our code in a single repository, which encourages reuse and visibility. People that say, let's say they want to talk to a Mongo database, they can look into our code base and then see, oh, I see that we already have a library for that, and it will be very easy to pull that in. Another consequence is that that particular library, we don't have versioning issues with that, because there is only one version of it in our code base. And I'll show you an example of that on how we manage that. So we have shared libraries in-house, which are sometimes just thin wrappers around existing libraries, but we add our own logic to it, for example, for monitoring or yeah, whatever we need. Um, and yeah, we've also created a sort of an institution. It's called Town Planning. That's based on a chapter in the Sam Newman book about microservices. Um, and yeah, because this is a place where we can discuss especially those layers which are um, overarching concerns. Like, for example, the deployment is something that anybody needs to do. So these are just tools that we need to develop together, and yeah, we need a platform to discuss these things. If somebody has a nice idea that could be useful to others, yeah, that needs to be discussed outside the teams. So that's why we created that. I will now show you some code. Um, okay, so I will show you some example of the common libraries that we have. These are our Scala libraries, and the front end libraries are also being shared. Um, and yeah, for example, we have a client to talk to S3, which many of our services need to do, and the good thing of having this just in our code base shared as code rather than as a versioned library is that let's say we are not too happy with the signature of this function, this get file, and well, maybe we want to add another parameter, or we might just want to rename it. Um, that would be a breaking change because everybody that calls get file, which we can see in our IDE, that's another advantage of having a single a monorepo is that we have type safety, and at compile time we already know what the effects will be, which is a massive boon to be able to refactor. So let's say I remember I renamed this thing. I would say I fetch file. It's maybe more fetch file than get file. Um, then this is changed, and yeah, in our entire code base, wherever this function is called, that was a bad example, but yeah, we see this thing being called, and all the services that will be upgraded to this new API. And because it's so easy to do this, it's also much more likely that it will actually happen. Because if refactoring becomes too hard, people will stop doing it, and then we get further and further bogged down in the spaghetti. Um, so if the dependencies are on library or basically code dependencies in the same technology stack, then we have all the benefits of having a strongly typed language. But if we have dependencies that, for example, between the backend and the front end, um, then we can't do that because that communication goes through our APIs. All the requests are serialized to JSON, and then deserialized on the other side. So it's a much looser connection. And then on the other side, it's used in a TypeScript environment. Um, so yeah, so these dependencies are still there, but they are less visible. And one way to deal with that is the concept of contract tests. So APIs, also known as contracts, um, they we keep examples of those contracts in our code base, again in our shared code base, and um, yeah, for example, our third-party service that we talk with. I already mentioned Navision before. That was the system that is taking care of the payment status. We have captured their responses and stored them here. Um, so let's say that Navision introduces a new transaction status, let's say cancelled. Then we can change that in our captured response, and our build will see that this change was made, and also which services depend on this file, and it will run the unit tests. So in this case, yeah, we were talking about invoices. So let's simulate that. Um, our invoice route tests. Let me see. Right, so we see that we have a failing test, which is what we want. And we see that that something changed in our contract. And this is the contract that of the our API. So this is the JSON that our API produces. Um, and we can fix this test by updating our contract with the new situation. So now we will see in our commit window that um, the contract for this endpoint has the new transaction status. Apparently, we're just forwarding this status as is to the client. But this in turn will trigger a test run for our front end code, which I will look up. So now I'm running one of our front-end tests, the test that is responsible for testing the rendering of our invoices, and you see that indeed it failed. Normally, again, this would be all triggered automatically by our build system. Because it's hard to remember that all the things that are dependent on these on this API. So you really want your build system to take care of that. And yeah, we can see the result here. Yeah, apparently we do nothing in our UI than just uh, removing the lowercasing it. And if we're happy with that, then we can just commit this change, and everything will be deployed in one block. So yeah, we make extensive use of these contract tests, and yeah, they are much more lightweight than traditional integration tests, where you need to actually launch all these services. And yeah, because this as you see, it's basically a unit test for testing APIs. Right. So yeah, those were just some practical examples of how we have dealt with microservices in our company. We have not backtracked. I think we're going to continue with microservices. We're going to keep on chipping away at the monolith. But as Jurian already said, we're not going to do this proactively. Whenever there is some change in our functionality, yeah, because of course, if it ain't broke, don't try to fix it. So if there is a change in existing endpoints, then we consider, okay, maybe we should take this opportunity to introduce another service for this. But I've left out a lot of details, like how the CI/CD works. Microservices will you will need to invest in monitoring as well, because you need to monitor many different services, which is harder to do than just monitoring one. And yeah, there's also a lot of impact also on the on DevOps and the infrastructure that I've glossed over. So yeah, it's absolutely not a free lunch, but yeah, it may be worth it. I would recommend to not start too soon. If you have a greenfield project, just start with your one service. Um, because you often don't know upfront actually how the domain should be divided, and only once you reach a point where you think, okay, now this service has having too many responsibilities, then you can start breaking things off bit by bit. And I think a very important principle to take into account is that designing it for replaceability, because a lot of good practices follow from that. If you make like the thought experiment, what would I need to do if had to replace this functionality? Then you, even if you never end up replacing it, it will still probably encourage you to create a clear interface, because then I know how this service is being talked to, and I know what all the entry points are, which if I need to replace it, I will need to address all those dependencies. And indeed, it also helps you to limit dependencies, because the more dependencies you have, the harder it is going to be to disentangle if you want to replace it. Yeah, and another thing we have taken sort of as a rule is to share our technology layers. So if I showed you the stuff we have in our common folder, there is nothing in there that relates to domain. In principle, these we could all release those as open source packages. So there are some things that are specific to Van der Bron, some choices we made, but there's nothing here about organizations or electric vehicles or gas consumption, etc. It's all basic stuff like talking to databases and doing HTTP requests. Um, because if we start sharing the domain, then we have linked the microservices and we've linked responsibilities, and then we run into the risk of the distributed monolith again. And yeah, so it also encourages you to design around the contracts, because the communication between the different services and front end and back end is always via interfaces. So often those are the first step we look at in when we start new features. First, we get the API right. That's where the discussion needs to be had, and then the teams have freedom on their own to decide on the implementation details. But we communicate to each other through interfaces, and then contract tests help you to guard the consistency of these interfaces and detect breaking changes. Well, using a monorepo I already discussed, and the fact that you need to invest in CI/CD. Um, so yeah, on balance, I would say microservices are a good thing, but you really need to know when to use them and what problem you're trying to solve. And yeah, you need a lot of investment in tooling and make design decisions that are shared among the entire company or department to be able to share the layers. Um, that's it.